In this tutorial video, we will be learning on Gaussian state. We will be doing the coding on Google Colab. Like we did in the previous video, we will be starting with the installation of Blueqat. Type the code, !pip install Blueqat in order to install Blueqat. Let us do it in Google Colab. Type the code that was shown earlier. And click on the play button to run the code. Blueqat will be installed after a while. Now, let us learn about the Gaussian formula. The quantum state of light can be divided into Gaussian state and non-Gaussian state. Calculations between states described only in Gaussian states can be formulated more easily. The Gaussian-Wigner function equation is shown below. As you can see, it is very similar to the classical Gaussian distribution. This equation has n-Q mode quadratures embedded in it. Like the classical Gaussian distribution, the Gaussian-Wigner function is also parameterized by first-order and second-order moments that are mean and covariance. The gate operation in the Gaussian formula is performed using this mean and covariance matrix. About the calculation efficiency of Gaussian formula. The Gaussian formula does not have the nonlinear gates needed to perform universal quantum computations in reality. In fact, the Gaussian formula uses the 2n times 2n matrix to calculate the Q mode number n. Since the computational resources increase only polynomially with respect to the number of Q modes, it can be efficiently simulated by classical computation. Therefore, it is not possible to efficiently execute so-called calculations that cannot be performed efficiently on a classical computer only with gates that can be handled by the Gaussian formula. Firstly, install PhotonCat and matplotlib, and then import the libraries needed. Now, basic gate operation. The displace gate in which the parameters x and p translates the state by re-alpha, im alpha on the topological plane. Type the codes, first initialize the parameter and use the displace gate. Then, plot the Wigner function. Then, the squeezing gate, where the parameters q and p squeezes the state on the topological plane. The parameter r refers to the strength of squeeze, where r greater than 0 for x direction and r lesser than 0 for p direction. When squeeze in a certain direction and the distribution becomes narrower, the distribution becomes wider in the direction orthogonal to it. Type the codes, first initialize the parameter r and use the squeeze gate. Then, plot the Wigner function. Finally, the beam splitter. A beam splitter mixes the light in the two modes. A beam splitter is an element that reflects R% of incoming light and transmits T% where R plus T is equal to 100%, which is like a mirror that transmits a certain amount of light. V and micro below are 4 times 4 matrix, and 4-element vector consisting of 2 Q mode, respectively. Gaussian formulas cannot directly handle photon count states, so they cannot simulate examples like the HOM interferometer. Instead, use displace gate to displace mode 0, and see if mode 1 changes after multiplying mode 0 and mode 1 with a beam splitter. Type the codes, first initialize the parameters and assign the mode 0 in displace gate. Then, 50:50 beam splitter is initialized. Finally, plot the Wigner function for the model. Thank you for watching this video.